All right, everyone, let's get started. Just a reminder that tomorrow is our first exam, and that exam will cover everything that we've done up through today. And I believe I'm only going to go as far as characteristics of graphs of linear functions. All right, and remember I said you could use a cheat sheet, or I was thinking about it, so let's make it formal. You are allowed a cheat sheet for a 5-point penalty. So the highest grade you'll be able to get if you use a cheat sheet is a 95. And that sheet can be a traditional 8.5 by 11 sheet of paper. You can write on the front and the back. You can have any steps, any formulas. You know, if you come up with your own code language that I don't understand, that's fine. You just can't have worked out problems. All right? Any questions on that? Yes?
Is it just like random letters as numbers?
Yes.
In like a
Yes.
step-by-step problem?
Sure.
Okay.
Just don't have anything worked out that's specific.
Okay.
Yep. And then also, of course, you can use the two conversion tables that I gave you, but I will not have any with me. So if you don't have it, you don't have it. You may use a calculator, but not your phone. Is that clear? So I'll feel bad if you say, hey, I forgot my calculator. Can I use my phone? I'm just going to tell you can't. So, did you get one yet? Yes? Okay. No questions about the exam? We're going to talk a little bit more about what will be on the exam, a little more specific towards the end of class. All right? All right. Well, let's pick up where we left off. And if you have any questions over homework, let's save those for when I'm done and I start talking about the exam. I can talk about any homework questions you might have. Anyone remember where we left off? I was showing you my artistic abilities. Remember that? Parallel and perpendicular lines. Okay, so, it was also pointed out to me that the homework packet from the bookstore, the notes or whatever, had 19 problems for section B, but the online printed homework only had 5 for section B. So that's, they told me that they just changed a few things. That's a pretty big, drastic change. So I will just say, if you did a lot of the 19, you're probably better off than just doing the 5. If you want to see more problems, if you only had the 5 and you would like more practice, then just talk to someone who has the bookstore copy and take a picture of it or something. Okay, so we were talking about parallel and perpendicular lines, and what we need to do is come up with a formal definition for each one. So parallel. And, let's start with parallel lines. Okay, so how do we define two parallel lines? What we say is two distinct lines are parallel if they have the same slopes. That's going to be our definition for two lines being parallel. So let me show you an example of this. As an example, if we take, I'm going to write it this way, L for line 1, colon, I'm going to let line 1 be this equation, y equals negative 2x plus 5. And then line 2, I'm going to call that y equals negative 2x minus 3. Then both of these lines, well, you know they're lines because you have an equation, right? You have two variables, x and y. Both of those variables are raised to the first power, right? So we know that these are lines. Since it is solved for y both of these equations are in this form, which we talked about last class, right? And so just by looking, you can identify what their slopes are, right? So what is the slope of L1, of line 1? -2, right? And if we wanted to, we could write that as -2 over 1, but it's the same thing, right? Rise over run. And then the next line has a slope of -2 also, right? And since they're the same, these lines should be parallel, right? Now there's another word in here that's important, and that is distinct. And what we mean by that is that we're not talking about the same line. So like if I were to say, hey, here's line 1, right? And then I said, and here's line 2. Are they parallel? Well, it's the same line, right? They're not distinct lines. So we wouldn't say that these two lines are parallel because they're the same. It's the same line. Okay? So back to this. Now if we graph these, I'll just do a quick graph. Don't worry about the graphing part of it. We'll get to that later. It would look something like this. One of them would go like this, and the other one would go something like that. Okay, those are straight lines, and they're supposed to be parallel. All right, so that's the idea here is that these are your y-intercepts, right? Because that's your b. So it hits up here at 5. That's this one. This one hits here down at -3, and the slopes are the same, so they should be parallel. Now, sometimes you'll see me abbreviate parallel with this symbol, meaning parallel, all right? So if you ever see me use that, that's my little shorthand notation for parallel. Now, what about perpendicular lines?
Intersect at a 90-degree.
Okay, they intersect at a 90-degree angle, right? So what's the definition? Well, we're just like parallel. When it came down to defining what it meant, we used the slopes to define parallel, right? Same slope, parallel. Well, with perpendicular, we're thinking of two lines that hit at a perfect 90-degree angle, across kind of, but it can be tilted, right? How are their slopes related to each other? Reciprocal and negative. So they're opposite in signs, and they're reciprocals of one another. So let me show you that. Two lines are perpendicular. I'm just going to put perp, okay? If slopes are negative reciprocals. So let me show you an example so you understand what negative reciprocals means. As an example, if I take line 1 and I say y equals -2x plus 5, that's the line we had earlier, right? And now I come in here with line 2. If I want these to be perpendicular, then what I have to do is look at the slope of this line, which was -2 over 1, and I need to take its reciprocal, right, which is this fraction what? Flipped, and then take the negative of it. So imagine flipping that fraction over, you get 1 over -2, wouldn't you? And then make it negative, so you'd have a negative of a negative, which would become positive. So the slope of this line must become positive 1/2. So would these two be perpendicular? Yes. Now what about the y-intercept out here? It could be anything. Okay, I could just leave it like that, right? The y-intercept would be 0. Or I could, say +2, or could I put +5? Yeah, I could still do it. These slopes would still be negative reciprocals. They would just cross at the same place on the y-axis. But it doesn't matter what number is here. These are still going to be perpendicular lines. Understand? Any questions? Okay, so the shorthand notation for perpendicular is that. This thing right here. It's almost like an upside down T. That's the notation we like to use to say two lines are perpendicular. Now, when you have two lines living on a flat sheet of paper, they could be parallel, right? They could be perpendicular, or they could be neither, right? They don't have to be parallel or perpendicular. It's not like a one or the other. There's a third option, and that's that they are what's called skew. But we'll just say neither parallel nor perpendicular. So now what I'd like to do is give you an example where I'm going to give you two lines, and I'm going to ask you whether or not they're parallel, perpendicular, or neither. That make sense? Okay, so let's start with this one. As an example, are the lines between 3, -2 to 5, -3 and -1, 5 to -3, 4 parallel, perpendicular, or neither? So I've always loved this word neither. Is that the correct spelling of neither? See, when I was in school, I was taught the whole I before E except after C thing. Right? How many of you have heard that rule before? I before E except after C? So why not here? That's not a C. So why is that not I before?
Sounded in A as a neighboring way.
Okay, so there's more to the rule, right?
Yeah.
Okay, that's why I'm a math person and not an English person. Because to me, a rule should always work, right? So if they tell me I before E except after C, and that's what they stress to me, then that's the rule I'm going to use, and I'm going to be a bad speller for the rest of my life, which is where I am. That's where I am. But don't call it a rule. It's not a rule, all right? Yeah, there's a bunch of guidelines. You have to, if it sounds like this, then this. How many of you have ever heard that stop signs with white borders are optional? Has anyone ever heard that before? Okay. It's not true. It's not true. But it's kind of like, it's like that's the rule, but sometimes it's not the rule. It just doesn't make sense to me, you know? That's what that to me seems like. A stop sign, but sometimes you don't have to stop. Okay, now, what are we doing here? We have two lines, right? One line goes through these 2 points. Another line goes through these 2 points. So what do we have to do? Graph it. We could draw it, right, and see if they look parallel or perpendicular. We could just find the slopes of both the lines, right? And that's the key to finding perpendicular and parallel. Is all you have to do is be able to recognize what's happening with the slopes. So let's call this line up here L1. We'll call this line down here L2. So for L1, how do we find its slope? How do you find the slope of a line through 2 points? We did this, right? y2 minus y1 over x2 minus x1. Remember that formula? So I'm going to call this the slope. We used the letter m for it, right? But this is the slope of the first line. So I'm going to subscript this with a 1 just so we understand this is the slope of line 1. And this should be equal to, if we wanted to get this detailed, we could come in here and label this as x1, y1, x2, y2, right? And then just start using our formula. So let's see. Good. A lot of you have your name things out. Good, good. So I'll call on the people who don't. Go ahead, sir. Do you have yours?
No, I wasn't here, sir.
You weren't here? Here, I've got one for you. Here you go. Fold it 3 ways. Just do what they did. However they did. And then markers. There should be one up on the board there. All right, but do you want to try this one? Do you know?
Considering I was not here Thursday, I would prefer to learn first.
Okay, okay. Well, remember the video of the lectures online.
Yeah, I checked the other day and it wasn't up yet.
Really?
Yeah.
Really? Anyone else?
I watched it.
You watched it? Okay. When did you check? Was it like the day after or? Okay, well. You were able to watch it? Okay, it's there. Double check. Should have 4 days of videos, day 1, 2, 3, and 4. Okay. All right, so who wants to volunteer this? Go ahead. What are you going to do, Jennifer?
I'm going to do -3 minus -2.
What would that give you?
You would get -1.
Yes. You have to just be careful with that double negative, right?
Yes.
Okay, and then
It would be 5 minus 3, which is a 2.
okay. So you said -1.
-2.
-1/2 is the slope of the first line.
And then for line 2, you would do 4 minus 5 over -3 minus parentheses -1. You would get -1 over -2.
Okay, try to keep up with you there. Yes? We good? And negative over negative? Positive. So this is +1/2. Okay, that's good, Jennifer. I'm going to let someone else, whoever, I'll let you volunteer today for a little while. And people don't volunteer, I'll call on you. So who's up? Who's going to tell me the answer to this? Neither one? Okay. These are not the same, right? They're off by sign. So you might be thinking, oh, perpendicular, they're off by sign. No, they have to be perpendicular but flipped, and it's not. So in order for this to be, for these two lines to be parallel, they would both have to be -1/2 or both +1/2. For these to be perpendicular, this one would have to be what? 2 over 1 or 2, right? So that's it. Understand? All right, let's try something a little different. Same question. Parallel, let's see, perpendicular, neither. That's the question. And here are the two lines. L1, 2x plus 4y minus 7 equals x minus 3y plus 3. And the other one, L2, is 1/2 x minus 4y equals 2y minus 4x. All right. So first question I have to you is, are these lines? Are these two lines? Well, I can move things around, right, and get it to look like a line, but I mean, just to start off, we can say that these are lines. These are equations of lines because there's equal signs, two variables, x and y. Each variable is raised to the first power, so they're both lines, right? But you can't just look at these right now and tell what the slope of the lines are. So you've got to get these to look like y equals mx plus b. So you have to solve for y. So each one of these is going to take a little work first, right? So let's start with this first one, L1. What would you do in order to solve for y? What would you like to do here? Y by itself. You want to go on the left side with it? Is that okay with you? Yep. So I'm going to get all my y's over here, everything that doesn't have y to the right side. So what happens when you take a term and you move it to the other side? What happens to it? It changes signs, doesn't it? Like this 2x, to get it to the other side, I would subtract and subtract, right? So it's really like putting a negative 2x on that side. To get rid of a negative 7, I would add, so it would be like a plus 7 over there. With me? And then this had a negative 3y on this side, and I want that to come to this side, right? So I would add 3y to both sides. Okay, so I'm not going to show all of that work because that's something you could do on your own. But let me just write down what it would be. How many y's would be on the left side? 7 y's. We should have 7 y's on the left side. Equals, how many x's on the right side? -1, right? Because you brought the negative 2x over, so -1x. And then anything else? Plus 10. Good. So again, if you can't get to that step, just make sure you go back and work it out yourself. Now that's almost there, right? We have to get y by itself. So to get y by itself, I need to get rid of the 7 that's being multiplied. So I divide through by 7, don't I? Now when you divide 7 on this side, you could do this, right? You could write it like that. But instead of that, I'm going to do something equivalent, which is to divide each term by 7. That's the same exact operation. And when I do that, this right here, I'm going to write it as negative 1 over 7x plus 10 over 7. And that just helps me see the slope a little better by writing the fraction this way. Questions? We're good? That's the slope of line 1, is negative 1/7. How about the slope of line 2? Well, same story, right? We got to move everything around. Y'all all right? Getting some confused looks. What do you want to do here? Bring the y's to the left again? Okay, so how many y's will we have on the left-hand side? Negative what? Negative 2 is going to come this way and join this one. Negative 6y equals, now this one's a little harder to do in your head, but you're going to take this, subtract it here, it's going to go away and subtract it here, right? So little side work here. I'm doing this and I'm taking away this, right? That's what I'm supposed to do. And to do that, you have to have the same denominator, don't you? So I need to rewrite the negative 4 as negative 4 over 1. And then the common denominator here would be 2. So I can rewrite this as what? Negative 8 over 2x minus 1 over 2x. And now you can put those two together. How many x's would we have then on the right side? What is it? Negative 8. Take away 1, right? So what? Negative 9 over 2x. Yes?
So when you subtract the half x from the left side,
Mm-hmm.
and then you subtract it from the 4x,
Yes.
could you not, why couldn't you add them? Like, so add the negatives and do 4.5x? Like negative 4.5x.
Negative
have a
4
mixed number.
Yes, you could have a mixed number, but when if you had negative 4.5 here, then you would have to switch it back to an improper fraction to be able to say what the slope is, right? And we're not done yet, right? Because we now need to do what? Divide by negative 6 in order to get y by itself. Now, I could divide by negative 6, or I could multiply by negative 1 over 6, right? Either way. What makes more sense to you? Taking this and dividing it by negative 6 or multiplying it by negative 1/6? What do y'all think? Multiplying? How many of you would prefer to do it like a divide? No? Okay, I'm going to do the multiplication. So I'm multiplying this side over here by negative 1 over 6, and I'm multiplying this side. I'm going to have to just put it out here, negative 1 over 6. And negative times negative is positive. 1/6 times 6, they reduce out. You just get one y here. And over here, what do we get? Y'all had a good weekend, huh? 9/12 x. Does that reduce? 3/4 x. Now it looks like y equals mx plus b. So what's the slope of this? 3/4. So what's the answer to this question? Neither again, right? I don't think I'm going to show you an example where they turn out to be parallel or perpendicular because I'm thinking it's obvious that once you get the two slopes, it's just a matter of comparing them. Can you all compare them okay? Any questions? Okay. Next example. Find the equation of a line, or of the line, parallel to y equals 3/4 x plus 1 with a y-intercept of -4. Anyone have any ideas? I'll draw you a picture. The line that we're given has a y-intercept of what? 1. And from that point, to get to another point on that line, what would we do? We would go up 3 to the right 4, right? Rise over run. So I should be able to go up 1, 2, 3, and to the right 1, 2, 3, 4, right? This is the line that was given to me. And what we're looking for is the equation of the line that's parallel to this line. So it's got to be parallel to this line, but with the y-intercept of -4. So 1, 2, 3, 4. There is a line that's parallel to that one that goes through, right? This is the one we want. What's the equation of that line? So you already know that because it's parallel, it must share the same slope, right? So it has to have the same slope as this line. So the line that we want must be 3/4 x. At the minimum, that's it, right? That's a parallel. Now it's just a matter of what's the y-intercept. And they tell us, right? -4. Done. Any questions? Is that pretty straightforward? How about this? What if I change the directions and I ask you to find the same thing but perpendicular? So find the equation of the line that's perpendicular to this one and still has the same y-intercept. So now I'm looking for the line that goes through here, this point, but is going to be hitting this one at a 90-degree angle instead. Right? What would change? Just the slope, right? The slope would have to be not 3/4, but -4/3, so I'd flip it and change the sign. And what about the y-intercept? Same thing, so -4. See the difference between those two problems? All right, let's do something a little different. I'm going to change this. How about find the equation of the line perpendicular to y equals -3x plus 1 that goes through the point five, 2. Ooh, that's a little trickier. So in terms of a picture, here's what I have. I'm looking for the equation of the line. Oh, this is different. I changed it. That is perpendicular to this line. So let me just draw this for you real quick. I would go to 1 again, right? And then what's my slope here? This is -3 over 1, right? Which means you would go down 3, right 1. Down 1, 2, 3, right 1, and then I could draw a line through those 2 points. Could I have done this instead, 3 over -1? Yeah, what would have happened had I done that? I would have gone from here up 3, left 1. And notice that, well, my picture's not too good. Those would lie on the same line, up 3 over 1. Got it? So we're going to draw the same line no matter what. So here's the line that's given. I'm trying to find a line, the equation of a line that's perpendicular to this one, but passes through this point. Notice this is not a y-intercept, is it? So if I go out 1, 2, 3, 4, 5 and up 1, 2, I want mine to go through right there like that and be perpendicular to that line. And I want that equation. Y'all all right with that? What can you tell me so far about this line that I'm looking for? Its slope is what? Is the negative reciprocal of that. So it should be what? 1/3 x. That's what I know about this equation so far, right? I do not know what this is, right? That's a question mark. I don't know what that is. So let me just call it b. Is that fair? If I knew what b was, I'd be done? Agreed? Okay, so now we need to somehow use this point to tell us what b is. Because it's kind of like we know what the slope is, we just don't know where it's going to hit the y-axis, right? If I could figure out where it hits the y-axis, then I could figure out like exactly where that is. So we're going to use this point right here to find b. And here's how it's done. Do you agree that this point represents the x and the y coordinates? It's like if you plug this in for x, this is what should get spit out for y. Yeah? Okay, so I'm going to use that. I'm going to erase it. We'll do it over here. So using the point 5, 2, I'm going to write this equation down. I'm going to replace y with what? 2. I'm going to replace x with 5 and plus b. And notice that now I have an equation that only has one variable in it, right? Just b. I should be able to solve this equation for b. And then I would know what b is, then I could come back and plug it in here to have the equation. So let me try and isolate b. First put these two together. That's 5/3 plus b. And now we will subtract 5/3 from both sides of the equation. So we get 2, take away 5/3 equals b. And to subtract those, we need a common denominator, which would be 3, right? So what minus what when I change it over? What minus what? 6/3 minus 5/3 is b. So what's b? 1/3. 1/3. And now you can come back here to the equation. We said, we knew everything but b. I used the point to figure out what b was. I can come back here now, replace that with 1/3. And that should be the equation of that line. So there's a little more involved with this problem than there was with the last one, right? If they give you the y-intercept, it's pretty clean. But if they give you a point, then you have to do some work. And I think if I were to draw this, here's 1/3, right? What? That looks pretty perpendicular. If you did it on graph paper, it would be better. But you don't need to graph it. I'm not asking you to do that. So this was just to give you some visual idea of what we're doing. That's all. Y'all seem all quiet. What's up? Did y'all have a bad weekend? Bad weekend? I had a bad weekend too. All right, so you should be able to do the homework from there. We are done with lines, and we are done with parallel and perpendicular lines. The only thing left, this will be the last thing for the test, are characteristics of graphs of linear functions. Now, I'm on camera right now, so I have to be very careful about what I say. So I'm going to offer, you like bonus, right? You like bonus? Let's see if anyone can get this. I'll offer 2-point bonus on the next test. If everyone can look at the table of contents on their packet, find where we are. So find where it says characteristics of graphs of linear functions. I want you to just kind of browse down through the next couple of sections, all right? And this might be a stretch. This is why it's a bonus, all right? Can anybody tell me why I have a major problem with the way this packet is set up right now with this section, specifically having that word in the section name? If you have an idea of why I have a major problem with it, just raise your hand and I'll... Okay, go ahead. What was your name?
DJ.
DJ, that's right. Okay.
Is it because maybe functions comes a little after that?
That's exactly right. Okay, so look. This is called getting the carriage in front of the horse, right? Here we are, everything we've been talking about, right? We've been talking about equations, right? Expressions, equations, linear equations. We did linear equations with one variable. Now we've been looking at linear equations with x and y. Then all of a sudden we're going to look at the characteristics of graphs of linear what? Functions. What's a function? Well, we're going to do functions later. So this should not say functions. This should say what? Linear equations. If we're going to be technical, which I like to be technically correct on things, then we should call these equations until we introduce functions. Once we introduce functions, then we can call them functions, right? Okay. All right, DJ, you got your 2 points. So what are the characteristics? Well, let's take a look at some different graphs. I'm going to draw 4 graphs up here. And I'll do them in red. All right, so I'm going to draw my first line. We know that if we're given a linear equation where we have x and y, right? Linear raised to the first power, that I could get something that looks like this. Right? That would have a positive slope, right? Positive slope. Something with a negative slope would look like this. So I'm just going to put up here, m is positive, right? The slope on this line would be greater than 0. The slope on this line would be definitely less than 0 because it's negative, it's pitched down. Also, on both of these lines, I have a y-intercept and I have an x-intercept. So these are characteristics of the graphs, right? I have some slope, I have an x and a y-intercept. Here, same thing, some slope, some x and some y-intercept. Y-intercept, x-intercept. Is it possible to not have an x-intercept? Can you draw a line that does not have an x-intercept? Yes? What would it look like? Straight line? Aren't all lines are straight, right? Straight through the origin. What do you mean straight? I think I heard it. Horizontal line. Horizontal line, right? Look, if I draw a horizontal line like that, it would have a y-intercept, wouldn't it? It would not touch the x-axis, so it would not have an x-intercept. But this is a very special line because its slope is very special. The slope of this line, does anyone know what the slope of a horizontal line is? 0. All horizontal lines have a slope of 0. Think about this. If I took 2 points, right? And I said find the slope between those 2 points, you would take y2 minus y1. Remember that in the formula? y2 minus y1 over x2 minus x1, right? But if they are both on this line, what can you tell me about their y coordinates? How high up they are? What? They're the same, right? So I'm going to take a number and subtract it from itself, and that's always going to be what? 0. So I'm going to get 0 over some number, and it's going to be 0. That's why we will always get a slope of 0. So I have a y-intercept, no x-intercept here. Agreed? Now what if I move this horizontal line down and put it right on top of the x-axis? I would have an infinite number of x-intercepts, right? So just because your slope is 0 does not mean you have no x-intercepts. You have to be off the x-axis to have no x-intercepts. Is it possible to have no y-intercepts? How? Vertical line, right? So what if I draw a vertical line like this? It's going to hit the x-axis. It'll have no y-intercept, unless what? I put it on top of the y-axis, right? What would the slope of this line be? It's an interesting question. So let me try and motivate the idea. Let's say that the slope of this line is 1. Okay, let's just say. Then if I said the slope of the line is 2, would that go up or down? Up, right? If I said the slope is 10, what would happen? Steeper. What if I said 100? Steeper. Okay, does it ever get this way, past 90 degrees? No, because as soon as you go past 90 degrees, then the slope is now what? Negative, right? So the bigger the number, the steeper the slope. So if I said the slope was a billion, that would be a very, very steep line, right? But not the steepest. The steepest line you could have would be straight up and down. But what's that slope? What's wrong with it? Think of the slope formula. If you pick 2 points on this line, aren't the x coordinates the same? And if you subtract something from itself down here, you get what? 0. Now 0 on top is okay, right? 0 divided by 4 is 0. But what have you always been told about dividing by 0? Undefined, right? It's not defined. And so we actually say here for vertical lines that the slope is And if you were to ever go into a calculus class, we would actually say that this slope is infinity. It's infinite. It's an infinite slope. Remember I was saying, 10, 100, a billion. What's that getting? Bigger and bigger and bigger? Approaching some huge, infinitely large number. All right.
Sir,
Yes?
would y over 0 be correct as well?
Would what?
Y over 0.
Y over 0. How do you mean?
Because regardless of what y is, it would still be perfectly up and down. Because divided by 0 would be a 0 movement sideways.
You can't divide by 0, though.
Exactly, but that's why it's undefined. Because you can't. But y over 0 would equal undefined, technically.
I'm not following you. Oh, wait. Okay, are you saying if someone gave you the equation y equals 0, you're asking me what graph is that?
It would equal y over 0. Because when you have no x change, which would be 0, it would simply be your y, which in this case would be infinity over 0.
We're talking about this one, right?
Yeah.
Okay, so look, let me just make up this point. Let's say this is the point 1, 4. Let's say this is the point 1, well, it is the point 1, 0. Do you agree with that? Okay, what's the slope? So you do y2 minus y1, 4 minus 0, over 1 minus 1, and that would be 4 over 0, right? The slope of that line is undefined. You couldn't say that it's y.
Well, y would be the 4 in that scenario.
Why are you saying y would be 4? Are you trying to come up with the equation of the line?
Well, that would technically be the equation of the line.
That's not technically the equation of the line. No. So would you like to know what the technical equation of that line would be? I'll tell you what it is for this one and for this one. All right? So let's look at this one real quick. What would the technical equation of this line be? If this is y equals mx plus b, this is y equals mx plus b, this also must be a y equals mx plus b. What's m here? M is 0, isn't it? So if m is 0, this equation turns into what? Y equals b. So it's just the y-intercept. So let me illustrate that with a specific example. If somebody asked you to graph this line, okay? Graph the line y equals 4. Then what you would do is you would say, my y-intercept is 4. 1, 2, 3, that's 4. And then I have no slope, which means it's a horizontal line. And I would draw a line like this. Understand? For vertical lines, you run into a major problem because you can't use this formula because m is undefined. So we use a different formula. X equals some number. I'll just say c. X is a constant. So let's see here. For this line right here, the specific example would be x is 1. So if I draw that, it's saying I have an x-intercept of 1 and all the points that have an x-intercept of 1. I'm sorry, that has an x value of 1. So don't all those points have an x value of 1? And the y is kind of free to do whatever it wants. Does that kind of clarify it a little bit? Okay. All right. Now, let's get into what you need to know. If most lines have x-intercepts and y-intercepts and slopes, with the exception of vertical and horizontal, then we need to be able to provide that information if it is requested. So if someone gives you a linear equation with two variables in it, they ask you for the slope of the line, the x-intercept, and the y-intercept. So let's do this. Example. Ooh. I'm trying very carefully to keep the reins on the horse here because you can go really off onto major tangents when you start talking about slopes of lines and infinite slopes and all this stuff because that's really where you start to get to the heart of calculus, okay, which I know none of you have to take. But calculus tries to deal with this question. What happens when you try and do 0 divided by 0? So, yeah, what is that? Is it what? 1? Well, I could see why you'd want to do 1 because like 4 over 4 is 1 and 3 over 3 is 1. You've always been told that anything over itself is 1, right? But you've also been told that you're never allowed to divide by 0. So what is this?
Infinity.
Take calculus and you'll see. Can't do it here. Sorry. But it was the fundamental problem, and it caused a lot of issues for a long time. And that's when Isaac Newton came around and kind of found a way to get around it and allowed us to do calculus. And it all grew from there. So, all right, example. Let's do this. Find slope, x-intercept, y-intercept of this equation. 6x plus 4y equals, we'll start easy, 24, negative 24. Has it ever bothered any of you, like, why you can't divide by 0? Has that ever bothered you, or you just don't care? What's that? No, I mean, we can talk a little bit about it after this if you want. I mean, we'll take a vote. If y'all don't want to see it, we don't have to talk about it. All right. What do you think? Slope first? Okay, slope first. Well, if we're going to find the slope, we've already done that, right? You solve for y. Get it to look like y equals mx plus b. So I'll do that pretty quickly. So the slope for y equals negative 6x minus 24. So what did I do there? Just move that 6x over to the right, change signs. What next? Divide by 4? Yep. And I'm going to do that same thing where I divide each term by 4. So what number should I have here in front of x? Negative 3 over 2, x. So I reduce the fraction. And then over here, minus 6. And that's enough for you to be able to tell me what the slope is, right? So the slope, if I'm answering that question, negative 3/2. All right. Next, I want to find the x-intercept. Well, is this going to be one of those special cases where it may not have one? We said the only times that's going to happen where you're not going to have an x or a y-intercept is if the slope is what? 0 or undefined. And definitely this slope is not 0 and it's not undefined. So we should be able to find an x and a y-intercept here, right? Now the way you go about finding these, there's kind of like 2 methods. All right? One method is pretty clean and easy for the y-intercept, and that's this right here. Don't we know the y-intercept? It's negative 6. Yeah? If we can solve for y, we know what the y-intercept is, and we're done. For the x-intercept, we actually have to do some work. So do what? Set y to 0. So yeah, let's talk about that. Remember that if you have a line, the point that it hits the y-axis must have what as the x-coordinate? If you're on this line, this must be 0. And then the y could be whatever, right? If you're on this line right here, this point on the x-axis, what can you tell me about that? What can you tell me about the y-coordinate? It must be 0. And then the x-coordinate is something, right? So the way that we find x-intercepts, that's an x-intercept, is to replace y with 0 in the equation and solve for this x. The way we find y-intercepts is to either just do that or replace x with 0 and solve for y. All right? So let me go after the x-intercept first. So I'm going to go after the x-intercept. To do this, I let y be 0. And I'm going to go back to the original equation. See, it's the opposite. If you want to find the x-intercept, you let y be 0. If you want to find the y-intercept, you let x be 0. So if I let y be 0, I write the equation 6x plus 4 times 0 gives me 0, right? So I get equals negative 24. Solving for x, dividing both sides by 6, what would I have? Negative 4. So that means that I have an x-intercept, and it's a point, isn't it? The x value is negative 4. The y value was 0. So that's my x-intercept. Now we already know the y-intercept, right? It's negative 6. We do? But let's act like we didn't even do that. And let's just see how we get the y-intercept from here. So we could go replace what with 0 this time? Let x be 0. And rewrite the equation. The x term gets killed off, right? Because 6 times 0 is 0. And then solve for y, you get y is what? Negative 6. And so the y-intercept written as a point is what? 0, negative 6. Now you may be asking yourself, why would I do this if I already knew that, right? That seems like a logical question. Well, what we're going to want to be able to do is graph these lines. Right? We're going to want to be able to graph these. So if I asked you to graph this line, you could go and solve for y, couldn't you? But you could also just get these 2 points, because how many points do you need to define a line? 2. So if I can just get this point and this point, draw them, I could just connect them with the line, and I'd be done. So it's sometimes just as easy to graph a line using this as it is to go ahead and get it to look like y equals mx plus b. So now it's time to see if you understand any of that. I'm going to give you a problem to do. I want you to find the slope and the y-intercept and the x-intercept, and I want you to graph the line. And then graph. So I'm adding one more thing onto this. And let's do a couple of these. We'll do part A. Let's do 2y minus x equals 4. Part B, 2y plus 1/4 x equals 2. And part C, negative 3x minus 5y equals 12. So take some time. I think we'll probably take a good 10 minutes here. I want you to go through the process of finding the slopes of each of these lines, finding the x-intercept of each line, the y-intercept of each line, and graphing it. Do you understand what you need to do? Yes? Okay. Let's do this on a fresh sheet of paper. Can you do that on a fresh? We'll do this as an in-class group quiz. All right? To be turned in today when I say time's up. So feel free to talk to each other, help each other out. On the top of it, just put your name and today's date. It is 6/17/18. Pardon me?
17.
Oh yeah, wrong month. Oops. Did I write that earlier? Did I put 6/19 for the test? I did. Oops, I meant 7/19. We already took it. I would like to not help you on this, so if you have questions, I want you to turn to your neighbor. And if the whole table's stuck, then you can call on me.